Okay, for number 12, I'm going to do the right board, but what it's asking for is a right endpoint Riemann sum where n goes to infinity. All right, let's go to the whiteboard. I'll walk through the material. There's no need to watch a video if you can understand what's written, or you can do it on your own, by the way. So let me go to the whiteboard, and we'll do this problem. All right, let me go to the whiteboard. And this is, again, number 12. Just give me 1 second. Let me get my pen out, make sure I'm using my pen again. So number 12. And I have f of x. And f of x in number 12 is 48x squared. And then it says plus 64x. The interval on which we're going to integrate is between 0 and 2. All right, so, it's certainly a parabola. So what I'm going to do is just, I don't really need to draw a picture of it, but I do want to talk about the interval. The interval starts at 0. It stops at 2. So what you're going to do initially is just simply divide the interval into n equal pieces. So the length of the interval is 2, and you divide it into n equal pieces. Now, of course, what I want to do, I want to let n go to infinity. So limit as that big N goes to infinity. And that's going to be the base of every single rectangle. If I'm taking a right endpoint, what I'm going to do is I'm going to evaluate the function f starting at 0, and I'm going to move over a little bit each time. What do I move over? 2 over n. You know what? I forgot to put the sum down, and I don't want to keep writing these things. I'll use summation to make it a little bit easier for me. We'll put limits down in a moment. F of, these are going to be the heights. The first height's going to be 0 plus, you're going to move over a little bit. That's how much you move over. And that's going to be, I'm going to use the counter j. And j starts at 1, and it goes off to big N. All right, that's the first thing you're going to write down. Now, someone says, what do you do about that? I'm going to simplify a tiny little bit, and I'm going to write limit. I'm going to write big N goes to infinity. The sum, j equals, I did it again, I forgot to write something down, and that's not good. That's 2 over n. And then the sum, j equals 1 to big N. And what I'm putting out is this over here, it's just simply 2j over n. And what are we doing with it? We're plugging into the function. So let me write that down for you. So it's going to be 48, right, times 2 over big N j squared plus 64 2 over n j, right? This is the thing we need to add together. So it's really a process of removing symbols. What I just removed there, the symbol f. Let me keep rewriting it. Equals the limit, n goes to infinity, 2 over n. Now, I'm looking at the sum, and let me see if I can figure this out a little bit. And this is j equals 1 to big N. And looking at this thing, I'm really going to do one term at a time, and it's going to be 4 times 48. Well, that's 160 and 32, so 192. It's going to be n squared in the bottom, and then it's going to be j squared, plus, let's see if we can do the next thing. That's 128 over n j. All right? So I'm going to keep moving, and I want to see if I can remove the sum now. So limit, as big N goes to infinity, 2 over n. I'm going to do one sum at a time. And what do you get? You get 192 over n squared times the sum, j equals 1 to n j squared. Let's do the next one. It's going to be 2 over n times 128 over n times the sum, j equals 1 to big N of just j. All right, and this is the part where I got to, maybe do a little bit more work, and I'm not ready to do a limit yet, but I'll write it down for you. Limit, by the way, it's a limit of this thing over here. So limit, big N goes to infinity, I get, let's see, 192, that's 400 minus 16, 386. Let me get my eraser out. Over n cubed. All right? Let me see if I said that right. 2 times, I said 400, that's 400 minus 16, I'm sorry, 384. Let me write that down. I have to check that again, by the way. I'm not using a calculator, I'm just using my head. 200, let me write it on the side, 200, 180, and 2 times 2 is 4. Yes, so 384, that's fine. And then I got to do this, the sum of the integers that are being squared, and that's from 1 to n. That's a formula that we should know, n, and then you're going to get n plus 1, that's big N, and then 2n plus 1 all over 6. All right, let's keep going. Plus, well, that's going to be 256 over n squared, and the sum of the integers from 1 to n, that's a big N, is going to be n plus 1 over 2. And that looks like a tough limit to do, but it's really not going to be that bad. So what I want to do is, I'm going to do something. I'm going to do some arithmetic over here. And I'm going to erase it after I do it, but I'm going to do 6 into 384. And it goes in a nice number of times, by the way. So I'm going to say 6. That's going to give you 36. And then you get 24. That's going to give you 68. All right? Let's see if I did that right. What did I say 8 for? I did it again. Maybe I'm getting weak with my arithmetic. I don't know why I said that. I'm glad I'm thinking about what I'm saying, though. So it's 24. Well, what time's 24? I'm sorry, what time's 60 to 24? It's 4. Sorry about that. That's going to be 0. So I'm going to write this down over here. Limit n goes to infinity. And then I get 64, right? So I did this. Let me get the red pen out here. I did this. I did this. Now I'm going to take this n cubed. I'm going to divide it into 3 different n's. So I'm going to divide the first factor by n. Let me put that down for you. That's going to be 1. I'm going to divide the second factor by n, which would be 1 plus 1 over n. And I'm going to divide the third factor by n, which would be 2 plus 1 over n. All right? I'm going to put a little thing here. I got to do that. Let me erase my bad arithmetic over here. Or my baby arithmetic, really. So what I'm going to do now, I'm going to do 2 into 256. You know, relatively simple to do. Again, when I say simple, I still make errors a lot. So it's going to be 128. And I'm going to take that n squared and divide it into 2 factors of n, and then divide into these 2 things over here. What would you get? Times 1 times, well, if I'm dividing n into n plus 1, it's going to be 1 plus 1 over n. Now, someone says, why would you do that? Well, for one reason, it makes it easy to take the limit. As n goes to infinity, what I'm going to get, 64 times 1. I'm clipping these off, by the way. As n goes to infinity, that goes towards 1. As n goes to infinity, that goes towards 2. We'll do that later. Plus 128 times 1. And as n goes to infinity, that goes towards 1. Let's put this down. We'll look at the key later, by the way. And what do you get? 2 times 64, 128. Plus 128. And what do you get? You get 256. All right? Now, granted, I do want to check it. And someone says check it with the answer key. Well, if you got an exam, I'm going to check it by integrating. And what's it going to be? 0 to 2. The integrand is going to be 48x squared plus 64x dx. I want to point out there's a lot of chances of making an error over on this one over here. Doing this over integration, generally speaking, it's error prone, but not that error prone. So let's write this down. So it's going to be 48x cubed over 3 plus 64x squared over 2. Limit of integration is going to be from 0 to 2. I'm going to go through the arithmetic. You know, 3 goes into 48 16 times. 2 cubed is 8. Plus 2 goes into 64 32 times. And 2 squared is going to be 4. Minus the lower limit, 0 plus 0. 16 times 8, that's going to be 80 and 48. And 4 times 32, well, let's see, 4 times 30 is 120, and then you get 8. Let's add this all together. 120, 200, 248, 256. All right, we get the same exact answer. Right, they asked me to do the limit, though, and I did that. I just want to quickly look over the work in the notes. And what I mean by that, go back to the notes and look at it. And I hope you're seeing something that looks very similar to what's written over here, by the way. But this is me talking through the problem. If I were taking an exam, this is what my exam paper would look like, by the way. Again, what's the hope over here? And again, you may be curious about this. It depends who the graders are. Some graders are very careful looking at the work. Other graders are just simply looking, does it look roughly right, and are they getting the right answer? If they're not getting the right answer, some graders are just simply graded as being all wrong. What am I looking for? I'm looking for notation. I'm really looking for this initially. I kind of follow left to right, make sure you could simplify those things and get what we're expecting. All right? And that takes time and effort on your end. I'd also recommend that you should be checking your work, if you can, by doing an integration. Thank you.